Now in this example we're finding the volume of the solid generated when the region between the curve y equals x squared and the x-axis from 0 to 3 is rotated around the x-axis. So we're coming down, we're going to rotate around this x-axis and end up with this solid trumpety sort of shape. Now, to get this volume, we use our formula, and this is nice and straightforward because it's rotated about the x-axis, so there's no complication. So we go straight to the formula. Pi times the integral from 0 to 3 of y squared. Y is x squared, so y squared is x to the 4th. And it's around the y-axis, so it's it's around the x-axis, so it's dx. That's a nice simple function to integrate. We keep our pi at the front, we add 1 to the index, divide by the new index, and we're going from 0 to 3. So we want pi times 3 to the power 5 on 5, and minus pi times 0, which is 0. So we simply have 3 to the power 5 times pi on 5 units cubed. As you can see, I've scrolled back to the introduction to volumes, and just wanted to point out that this example here is a little bit, the function is a little bit similar to y equals x squared. We don't know exactly what's going on with the rest of the function, but certainly that little bit, it could belong to a parabola, and it's being rotated around the x-axis, and the boundaries are, well, we don't really know, but there could be something like 1 to 5. Here we can clearly see that we're being told that this is a function of a trig function, so it's called 2 sine x. Now we know that sine of x does this, up and down and up and down, and 2 sine x, which just means a little bit steeper or taller, and it's being rotated around the x-axis, and like I said initially, we don't know the name of that function. It's not given, so I suppose theoretically we can't find its volume, and the diagram is just there to demonstrate getting the volume. Now what we're going to go on to is volume around the y-axis. So we have our function, and it's usually given in its standard form is as y as a function of x. The reason it's given like that is because we're more familiar with drawing it that way. We can sketch our graph when it's in the form y equals something about x. We've spent all this time learning how to graph, and that has basically been the format. However, now when we come, and we are just going to be rotating this curve, this time around the y-axis, so we'll get a similar shape over here, and we're creating a solid around the y-axis. Then the formula becomes volume equals pi integral a to b, so in this case our a would be 0, our b would be 1, of x squared dy. So we're going to be needing to make x the subject and then square it. What you're going to find is a lot of the functions, when you make x the subject, they will have a square root in them. That is just because you ultimately then will square it for the volume calculation. So they set up the functions such that when you make x the subject, you've had to take a square root. But that all gets sorted out because, remember, you're going to be squaring x. And when you square the square root, it disappears. This is just another example. And this again could be, this could have been a parabola. Coming down, going around. But now rotating it around the x-axis would give us this shape. Similar shape, but it's now upright. I think that, yeah, I've probably got time to do the example in this video. I'll just pause it and scroll down and get the solution set up. As you can see, I'm not going to do the example in the notes first off. I've added some more examples in pages underneath our notes, and I think it's probably easier if we just go into this gradually, and because really we're focusing on establishing the formula. So in this example, you can see that you're given a curve. It is already expressed, that curve is already expressed with x as the subject. So I would consider that they've made this quite easy, which is a good one to start with. It's a nice easy one. Let's start with that. So we want the volume created between the curve and the y-axis from 0 to 1. So our volume is going to be pi times the integral from 0 to 1 of x squared. And like I said, you can always expect that to have a square root because in your original function somewhere, because you know that you're going to need to square the function. That is the rule for calculating the volume. So we would want x squared. Oh, I'll write it like that. I'll just write the formula to y. So the volume is equal to pi times the integral 0 to 1, and x squared becomes root y squared, which is just y dy. So the volume is pi times, nice and easy to integrate, add 1 to the index, divide by the new index, we're going 0 to 1. So the volume is pi times a half minus pi times 0. So it's, the volume is just pi on 2 units cubed. I'm going to come back to this one. But let's get the little routine established and let's get confident with the process before I come back and talk to you about that